Alright, this video is basically just going to define a few terms, and we'll get into the specifics in some other videos here. But I'm going to talk about standing waves and resonance. A standing wave is something that doesn't necessarily appear to be traveling, but it's simply oscillating up and down. Sometimes I like to think about just like a jump rope. Like if you watch somebody jump rope, it just looks like the rope is, oscillating up and down and up and down and up and down. You can kind of think of that as what a standing wave would say look like. I'll also bring in a drill and a piece of string to show you guys different types of standing waves when we come back to class. Parts of a standing wave that we'd like to talk about are things like nodes and antinodes. If you look at the definitions here, nodes are points of destructive interference where the particular wave would appear to be still at all times. So again, if you think about jump ropes, this would be where the person's hands would be. And then antinodes are parts of constructive interference where the wave oscillates between positive A and negative A. So that would be probably right above your head and above your feet, or below your feet. Okay. Something that's a bit more interesting to talk about is something called resonance. If you look at the definition, it says the tendency of a system to oscillate with greater amplitude at some particular frequencies. If you've ever seen any footage of, say, like a bridge collapse. Well, why exactly did it collapse? Well, sometimes it's due to what's called a resonance frequency, where perhaps the structure itself, if you shake it at the correct frequency, will start to oscillate. Okay, if there's some other source that is also producing a very similar frequency, you get a raised amplitude. So I've got a little graph here, and this is something that pops up with IB students quite a bit. They'll show you the amplitude versus a frequency, okay, where the natural frequency is here in the middle. Okay, so if this was a bridge, this would be the frequency at which the bridge would start oscillating. Not a good thing. But say you had another object, say a train, and the vibration of the train going by would either help or hurt the natural frequency of the bridge. If it is going to go ahead and create a resonance with the bridge, what you get then is you get a peak at that natural frequency, which would cause it to oscillate at a greater amplitude. Okay. I've drawn a couple different curves in here. One that's got a big peak on it because it's lightly damped, meaning there isn't any type of like shock absorbers to kind of absorb any of that energy at all. So you get this huge peak in amplitude. Again, that's kind of what would happen if, say, the bridge was going to collapse or something like that. Hopefully, engineers have gone through and come up with ways to damp that particular vibration. And if you do that, then even if something does go by with the same frequency or create the same frequency, you don't get a huge bump in amplitude, which could create a pretty bad disaster. Okay, so these are some definitions here that we're going to work with, and I'm going to get into more specifics in following videos.